Chemo. So good morning and kind of welcome to Goldsmiths. Thanks a lot from the Juice team for actually having us here. And we're excited to speak about the native control standard. My name's Ray, as Timo just mentioned. This is Tim. He's looking after complete control at Native Instruments, and we've got Eike. He's the lead developer for NKS. So if you're not familiar with NKS, it's our extension to the plugin standard for all virtual instrument developers. It allows for seamless interactions between plugins and for complete control, machine, hardware and software. It's been out on the market about 12 months now, and we've had 35 developers and 130 instruments. So we're very proud of that in a very short space of time. We've had quite a lot of industry leaders basically implement their products. So you can see we've got Arturia, Yuhi, Heaviosity, Sound Iron and Spitfire. As developers, we believe that you know your instruments the best. You've got the vision for the product, you've been developing it, you've been fixing the bugs. And that's why we believe it's important for the developers to actually work on the integration themselves in line with the vision of the product. So I'm going to hand over to Tim and Eike now, and they're going to run you through the SDK. Tim from a perspective of a user, and Eike is going to open the hood and look at what's involved technically. Please, Tim.
Thank you, Ray. So the first thing to do is just talk a little bit about the agenda for this part of the presentation. The SDK is divided into two parts. The first part is guidelines, sound design guidelines. So that's all about maintaining consistency. The second part, which is what we're going to look at by looking at these four things today, is the technical documentation, including some live coding, which is obviously where the interest is for you guys primarily. So what we're going to show you over the course of the next 50 minutes or so is just how easy it is to make your virtual instruments support NKS. So starting with the first thing, which is unified preset browsing. So what's the problem here? Well, we know that users have access to many, many great virtual instruments. Many of you represent those instruments here today. And of course, we want them to use them. We make instruments, there are a number out there, we know people want access. And currently browsing in hosts is by default this engine-centric experience. So what does that actually mean? Well, what it means is that you have to know which plugin you want, generally speaking. You have to remember which preset within that plugin, etc., etc., etc. So finding sounds can be difficult. Add to that, of course, there's a multitude of paradigms for browsing. Not a bad thing, but it does make it harder for the user to think, okay, I'm in this plugin, this is how my browsing works, I'm in this one, so on and so forth. And in the end, what all this means is that it's hard to remember and find sounds when you're looking for inspiration or when there's something specific that you're after. So to address this problem, we introduced something that we call Native Browser, which you may have seen. And what this is, it's a unified preset-based browser for all Native Instrument and NKS virtual instruments. And what it allows you to do, it allows you to search across all of your products using several different entry points. So anything that's NI or NKS, you're going to be able to search across. And it introduces a common browsing paradigm. So what we're really aiming to do here is make browsing secondary to finding your sound. It should feel very much in the background, not like something that gets in your way. So I'm going to demonstrate this little aspect very briefly using, in this case, complete control. But of course, all of this is also relevant to Machina controllers, Machina software. It works in exactly the same way. So I'm going to press browse here on complete control. And what you'll see, hopefully, so you'll see complete control here showing my browser. And you will also see on the screen complete control software, which we can keep open or closed. It really doesn't matter. It's generally running as a plugin. I'm using the standalone just to keep this demo a little bit smoother. So what we have here for the browser, if you look at the keyboard, we have a set of filters. And what the filters do, they take this big list of presets and they gradually focus it down. And the way that it works, you have filter granularity increasing from left to right. So I'm not going to go over it in huge detail here and give you a big demo because we're more interested in what Eike's got to show us. But essentially there's two ways of looking at things, two very common searches if you like. The first one is what I call the I know what I want search. And this is where you perhaps know exactly which product from exactly which vendor, perhaps even exactly which sound. And to do that, I'm going to use generally the left-hand side. So starting with vendor, I'm going to change this over and I'm going to choose Heaviosity. And you'll see that also changing in the software as well. I could do it in either place, just using the hardware right now. Then I'm going to choose from products, I'm going to choose Gravity, which is a Heaviosity product that I really like. And I'm just going to jump in and load the very first preset by hitting enter. So that's a very easy way of finding, okay, I know which one I want, quickly get there. The other one, which I always think is actually a more interesting search, I'm going to go back into my browser, is what I call the kind of inspire me search, where, okay, you know, I know that I want a synth lead, and I know I want a classic mono lead, but actually I don't know what engine I want to be powering that. It could be anything. I own maybe 70 different instruments, and I just want to look across all of them. So for this one, you're generally focusing a little bit more on the right-hand side, where you've got types and modes. Of course, you can use all of these together and gradually get more linear, more focused in your search, or you can just jump straight in, for example, to types. So I'm going to choose here, continuing with the search I was talking about, I'm going to choose synth lead, and I'm going to choose classic mono leads. And I could go a little bit deeper with modes and various things, but I'm just going to stick with that and load the very first preset. And what you'll notice once this is loaded is that I'm now using a different instrument, which actually isn't made by Native Instruments or using Kontakt. So the very first one is actually from Urs Heckman, UHI plugin called Diva, just waiting on that to load. There we go. Sorry, I'm mistaken. It's Monarch. So just goes to show inspiration, right? I've got something different, not what I expected. So Monarch is one of our ones, a Raptor-based plugin. And if I like that sound, I can work with it. Alternatively, I could jump to the next preset. And that happens to be Urs Heckman's Diva. Totally different instrument, but again, a kind of synth lead sound in that vein, something that's sort of in line with the sort of thing I'm after. If I jump into the browser, I could just jump down a few more options, load up yet another one. This one's Rob Parpin. So this is coming from Blue 2. And again, it's a synth lead sound, but 3 engines that I've just crossed without leaving a very, very simple browsing paradigm. Now presets, the presets that I'm working with and loading here, they all use a single file format for every NKS VST plugin. And the products and tags that you see that I was searching through there are provided in the NKS SDK, and they exist in the browser because of the preset files.
Yeah, thank you very much for this introduction towards the NKS SDK. So as we just learned, all the products that you see in the browser exist because we have presets for them. The preset is the final anchor that actually puts the tiles there, that puts the entry into the result list. So the entry point for you to create an NKS-ready product is to create presets for your plugin that come in the NKSF file format. The NKSF file format is nothing very fancy. It is a very simple format that combines established industry standards, which is on the one side the VST chunk serialization. That is the current serialization technique you will use in any VST host. So if a user saves the DAW project, you will have to transfer your plugin state into this chunk. The DAW saves it somewhere and gives it back to you once the project is reloaded. We use this technique to store your plugin's state into a preset file. On top of that, we put chunks that contain structured data that make all the magic happen for the browser, so enable us to do the filtering, the tagging, and the display of the products. So let's dig a bit more into what exactly an NKSF file is. So as we've just learned, each single preset is a single file, so it's the direct one-to-one mapping there. So we take the identifier of the plugin, so each VST, as you may know, has a 4-byte identifier. We take that, store into an NKSF file. We pull the chunk, store that into that, and then on top of that, add data that you provide in that case for tagging and categorization of these presets. So let's dig one level deeper and go even more detail. So NKSF file uses the RIF file format. That gives us the outer frame of that file, containing an identifier, what kind of file we have, and the size. And then we have variable size chunks inside that file that allow us to store arbitrary binary data in a sorted and orderly manner. But on the other side, we are able to stream these very efficiently out of that file. Each chunk has its own 4 character identifier. And we also add a version here. That's not the original intent of RIFF, but we want to be safe in terms of forward and backward compatibility, so that once the format changes, or we decide that we store different information into a chunk, we're safe on that regard. We can discern the formats inside. So again, the current chunks we're talking about is a plugin identifier, the chunk from the plugin, and on top of that, we will store what we call NI sound information, or the browser chunk that holds the metadata. Quick recap, what RIFF in technical terms is. So we have this header format, which is each 3 times 4 bytes long unsigned integers. It always starts with a 4-letter identifier, and we store an unsigned size. And if we have the file header, we have an identifier. If we have a chunk header, we store a version. So let's look into the browser chunk. We use inside the browser chunk, or actually in all the chunks we use for additional metadata, we use MessagePack to store structured data. We'll look into MessagePack in a minute. We use key value maps that MessagePack offers us to have a high forward-backward compatibility, meaning we can store keys that an application may decide to use, or it may not decide to use. And that way, we think we're in a very good position in terms of forward-backward compatibility, because if we find the application finds a key that doesn't know, it can ignore it, or it can also even store one that another application may not know. But it's still, if the applications are made in a sane way, they can still communicate with their own proprietary information. Exactly. So, go one step further, please. So let's talk about MessagePack for a second, because that's something maybe not everybody is familiar with. It's also straightforward. MessagePack is, you can basically map one-to-one to a binary representation of JSON. So if you know JSON is this human-readable format that offers you the notion of associative arrays, so key value maps, arrays, and a set of Boolean and numeric and string values. MessagePack has the same notion, just that it is a bit stricter on the type system, and it has a very compact and very efficient binary format for these. In the SDK, you will find tables like these that show you which keys can be stored in the various chunks, which type they are to be expected of, and if they're required or not, because some of them may be optional. And to show you actually how you can use this file format inside your code, and how you can write code that creates these files, say if you want to either adopt the format completely or you want to batch convert existing presets, I'm going to give you a little code demo, in this case in C++, that will write a valid NKSF file in the end. So I've already prepared here the outer frame, which is writing an RIFF file. I've prepared this because I think we can go through this rather quickly, because it's nothing really special. Here we find a structure that holds this header structure I've shown to you earlier, which is this 3 32-bit unsigned integers. And writing a chunk is then basically filling out the structure. Writing them, in this case, I use std streams to an output stream. And for RIFF, you have to add padding to the chunk, so you always have to land on an even stream offset boundary, so you have to eventually add a padding byte. So it's really straightforward to do these things. In the same manner, I can put together a whole file. So I have the same structure again, the header structure. I fill out the fields. In this case, I'm already set up to write this file to my user content, so we can actually see it in the complete control application later. We write the header, allocate the space for the header, write the individual chunks, get the file size, put it into its place, and we're done. So since this is not so interesting, let's look into how we actually write the MessagePack information. So I already set up here a function that will write the identification chunk. It's the easiest one. And here I have a little pseudo representation of that chunk in JSON. And we want to translate this into MessagePack now. I already set up the include for MessagePack. On C++, that is a single header include, and it's header only. So you don't have to fiddle with linkage. You You just include this header, have the header in your header search directory, and you're set up and done. So let's start. You see here, this structure is a single key value list with a single entry. And for demonstrational purposes, I will show you first the low-level interface, and afterwards I will show you how adapters towards STL and higher level concepts work. So the low-level interface of MessagePack starts with creating a packer object that is actually a template on a stream object. In this case, I will just use the string stream from the STL. So I have to create one actually here. Which is a temporary object I want to pack my binary message pack into. Create this object and pass the stream in. With this low-level interface, I have now to go piece by piece and pack the individual parts. So I have to start with, pack map, which signals to the stream we're now expecting key value map. I have to specify the number of elements I'm going to store in terms of key value pairs. And then I'm expected to individually serialize keys and values in an interleaved matter. So next, I have to pack the string key, have to give the size to it. Using std strings makes this also easy. Then I have to pack its actual body into it. So using the raw pointer I get via the data function. And since it's a raw pointer, it's always good to have the size next to it. And that would pack the string key, which is this VST.magic. And finally, I pack the actual identifier, this case is 32-bit unsigned integer. As we call all these lines, they will write directly to the stream. So I finally can use my Redshank function to write to the file stream. Here I pass in the identifier. Here I have the plugin identifier chunk. I pass in the version, and then pull out the data from the temporary buffer. This obviously is pretty cumbersome, and also you may agree probably that this is very error-prone. So I have to know how big the map is in advance. I have to deal with the internals of how the MessagePack structure works. So probably this is nothing we want to actually use. It's just for demonstrational purposes that you get a feeling what is actually going on behind the scenes. Fortunately, the standard MessagePack C++ implementation already comes with adapters towards STL classes, and actually quite a lot of them. So let's replace this by modeling our data accordingly in STL. So since we have a key value map, let's create an std map. Like redoing the obvious thing, mapping a string to this integer, give it some name, and then use straightforward C++ to store the data. And now all we have to do is use a single function called pack, taking the stream to write to, and the object we want to serialize. And this is doing exactly what we want. So these 4 to 5 lines actually go into this one call to the pack function. And it does everything, it handles everything that we wanted to do. So that was actually easy, and it was more an introduction towards the format. Let's move on to the bit more elaborate chunk, which is the browser chunk that holds all the metadata, like the tags, your vendor name, the product name. In a similar matter, I know I can now use the STL, so I can start modeling the data. So the whole metadata chunk is a plain key value map. So let's start with the map again. My keys are all strings. I'm also mapping to strings here as well. So let's start out and put in the required fields. So the SDK will tell you that these fields up here are the required ones. So you have to put a preset name, obviously. You put your vendor name. You have to tell whether we are loading an instrument or an effect. And we have to store the banks, which is important because it holds your product name and is relevant for the sorting in the end. So let's fill in some data I prepared here. Oops. actually a name. And the same thing. Obviously, you can write code probably that does that in a more elegant way. You might actually vary where you come from. I prepared most of the data here as being just constant, string constants. Obviously, if you have conversion code or you adapt it, your source may be different. It's more about the technique that I'm going to demonstrate to you here. So we have an instrument at hand. And now I have the first real problem, actually, because now for the banks, you look up into the SDK and it tells you have to serialize an array of 3 strings. And this has to go into the value of a key value map. So our mapping from the STL map breaks down at this point because the string on the right-hand side somehow doesn't work. Luckily, the MessagePack implementation also provides adapters towards Boost. We have a single header, maybe you've seen this before, so when I include a MessagePack header, I have this define, MessagePack, please use Boost. I have to have Boost in my include in my header search pass. And this enables me to derive a very powerful type system that, admittedly, in C++, the strict typing of C++ sometimes is a bit wieldy, and if you try to do stuff that you would do in scripting languages where you can just freely assign types left to right, is sometimes a bit unwieldy in C++. But fortunately, Boost provides a type that's called a variant, that you can is a template over a type list that can go into can represent different types in the same amount of memory. And the MessagePack implementation uses this and introduces a variant type. So here we'll create a type that I call, in this case, a value, which will be able to hold any type representable by MessagePack. And I can make a type alias towards the MessagePack type variant. And now I can create a map. In this case, std map. I know I always will have string keys. The SDK defines or requires you to use string keys. That maps to this value. And in the same manner, I can also define me an array type. In this case, I will just use an std vector over these values. And now I have these fundamental types that I use for this chunk. So to now finally write my read strings, my array of 3 strings for the banks. So I say keys banks. I can write something like array. And now put in the initializer list my, let's say, product name. And maybe soundbank1. Oops. What is interesting to note, this is a little tech note on the side, since it's a developer conference, let's spice this up a bit. Maybe some of you remember this line. It was printed on some t-shirts for a C++ conference at some point. Probably came with the introduction of C++ 11 or something. Where obviously you can't use automatic type inference on an initializer list that doesn't know which different types it takes. But in this case, we just have to change one word here. We tell it which type it is to the left-hand side. Now I actually can write such an array. Doesn't take it here. Oops. Obviously, I have to change my map to my new map type here to accept that array to the right-hand side. So I can also now go ahead and add tags for my presets, for instance. So say types, so the high-level tags. And the types are supposed, as per the SDK, supposed to be arrays nested with arrays. So I want to serialize an array. And I fill this array again with arrays of, say, type 1, subtype 1. And let's say I want to have another tag below that, top level type 1, subtype 2. This is a pretty convenient type system to use for runtime typing in C++, powered in this case by the Boost variant structure. So finally, since all these adapters are coming from MessagePack, obviously I can just, again, create me a temporary buffer to write to. And finally use MessagePack to serialize the structure with one single line, with one call. And it does exactly what I expect it to do. And finally, we write this chunk to our file. The stream, this case, the sound information chunk, version 1, taking the data out of this temporary. So I've just shown you, we've actually now compiled a NKSF file, which stores an identifier towards a plugin, which stores metadata. I have left out the chunk a bit because the chunk is basically literally put into plain binary data. There's no magic going to that. You just open another RFF chunk and just dump whatever you need to serialize your internal state into that. We won't touch it. We just hand it back to you once we load the preset. So if I run this, this actually already creates a valid preset that if once I rescan my user library, pops up in complete control, and it has these types that I just assigned here. So what did we just do? Quick recap. So we've seen how presets are at the heart of NKSF. They actually bring your product to life in the browser. I've shown you how to use RFF and MessagePack to write these files from your own code. How this is based on the existing chunk technology, and how you can use STL and Boost in C++ to help you to deal with type variants at runtime in C++.
Okay, so you've seen how simple it is to get your preset files into the browser in the most basic form with some basic tags. There's a few other things that we want to offer. So I talked earlier about the I know what I want search. And usually if you know what you're after, you're looking for a product. And we want to make sure that that search is very fast, not only from the hardware, which is what I showed you earlier, but also from the software itself. And speed in the end in this way is promoted by using additional cues. One of those cues is the visual identity of products. So rather than a flat list of text, which can be very, very hard to take in, you actually have some visual cues and artwork, tiles in fact, in the software. And you'll also see these on our Machina Studio hardware screens if you're browsing there. The second thing is short names and hardware labels. So text is obviously also important, but we know that long strings can be very difficult. So you can give your plugin or product a shorter name, which will allow you to find it easier. So just to show you this in the software very briefly, this time I'm using the software browser over on the left-hand side. And you'll see here that all of the things that I've got installed not only have really nice short names without any truncation, but they also have a tile that really helps me to visually scan through the list and very quickly find exactly what I'm looking for.
So let's quickly talk about how this actually technically works. So all the artwork you see are just bitmap PNG files. In the SDK you will find an exhaustive guide that tells you how to create these files, what format you're expecting, and also have some guidelines on what this artwork should represent. You basically package all this up in a folder structure. In the SDK we prepare templates for you that you actually just have to fill in. And you package everything, put it into your installer and ship it with your product, and you're basically there. As Tim just talked about the short strings and the name abbreviations, these go into JSON files, having specified keys. Again, we have templates for you for these, where you just have to fill in your desired product abbreviations.
So moving on to the next section, that's everything to do with the browser. Very, very simple to get in there, and as you saw earlier, makes it very easy to find things, which is in the end what we want for all of our users. So the next part, we know that presets are a great way to find instruments and get sounds and get inspiration, and we all ship a lot of them with our virtual instruments. But actually it's customization of those presets that invites the next level of inspiration. Many virtual instruments, if not all virtual instruments, are very customizable, and they give you, of course, we all know, deep editing options and all sorts of things that you can do to make that sound your own, maybe starting from a preset, maybe even starting from scratch. Now that's great fun and something that I'm sure appeals to everyone here, but speaking to a lot of users, what we know is that they often feel quite overwhelmed because, of course, we all have different paradigms, different synths. Now this is a good thing, it's a big part of the fun, but it can put people off in terms of just getting in there in the first place. So what we offer with the SDK and with Complete Control and with Machina is this macro level. And that provides essentially a simpler entry point for people to start playing around with the sounds in the hope that actually they may go beyond that then and start digging deeper at a later point. So it really just strips away some of the abstraction, makes it very, very simple. It also makes these things very tangible for hardware controllers, where we have standard configurations of 8 knobs, and it means that you can control things, make adjustments to the sound in a very, very easy way from hardware as well as in software. And this is something that we call native map. So I'm just going to show you this very briefly. You can already see it, in fact, for this instrument on the screen of my Complete Control hardware. You'll see that everything's labeled. And the way that it works, it's divided into 3 things. At the top level, we have pages, which I can move between. And the next level down, we have sections. So you'll notice on the bottom row on my hardware, I've got sections that group controls, and then, of course, parameters, the controls themselves. And I can show you this in the software as well if I open up this area. Now, this actually directly reflects what I'm doing on my Complete Control hardware, or if I'm in Machina, on my Machina hardware at all times. And what I'm going to do is just show you very briefly how you can either adapt an existing preset because maybe you don't like the layout, or more likely you're going to create this when you're creating your presets, create this from scratch to make sure that the people who are using your instruments can really have the most useful controls right at the start. So what I'm going to do is just show you how easy this is. I'm going to unlock the area, and I'm going to do it via Learn. I could do it via a drop-down list of automation controls, but I'm actually going to do this via Learn because it's slightly quicker and easier. So select this one. So all I need to do now, and I'm just going to learn the attack, decay, sustain, release on the amp. Just move these controls, and there I have them mapped. And I can now give them names. So I'll just call them ADSR for the sake of speed, but this can be anything. And you'll notice that as soon as I change this, it all updates on my hardware as well. And we'll get rid of these, and we'll call the section envelope. And there we go. So I've now very, very quickly mapped, and you can see them all moving, my ADSR controls. And if I want to, I can save this. It'll write a new NKSF file. Now, something Ray mentioned earlier, we really believe this is important, so worth reiterating, is that the native map is defined by the people who make the plugin, by your sound designers or by yourself, if that's how your company works. And the reason for that is because we want to make sure that you can present your virtual instrument in the way that you want to present it, both in the software, but also on our hardware. So again, here we're talking about Complete Control S-Series hardware, our keyboards, and our family of Machina controllers. So you can choose how you do that, how you want to present it to the user. The NKS SDK, as I mentioned earlier, includes guidelines. This ensures that there's some consistency by giving you suggestions on how to group things. It's not something that we force because there are so many different ways that you might want to do it, but it's something that we encourage just to give a sense of familiarity, particularly for users who perhaps aren't so familiar with editing complicated synthesizers and so on. And the important thing to know about this mapping, the mapping is actually specific to each individual preset file. So with that being the case, the information is of course stored in the NKSF preset file itself.
Yeah, as just mentioned, we have the mapping for each individual preset. So obviously that means we have to store it there. And we do this by just adding yet another chunk, which we call the native map chunk, which carries the identifier NICA. Here I have a little pseudo JSON representation of this chunk. So again, we have a key value map at the top, ensuring forwards-backwards compatibility, or even the adaptation of other controller layouts at a later point in time. Currently, we carry everything under the NI8 knob layout, which is this NI8 key you will see here. And this expects you to write an array of the parameter pages, so each set of 8 parameters displayed at any one point in time. And inside each page, you have an array of exactly 8 parameters, where each of these parameters is a key value map again. In the SDK, you again will find a table that explains each key that is expected for the single parameter and explains a bit what it does. Also, you find some additional information about whether they are required, optional, and some additional functionality that is available there. So again, let's complete the preset we've done earlier by completing, sorry, close that. Completing our preset with a native map chunk. So depending where you're coming from, your data input may look a bit different. What I've done here, what probably most of you will do, we will have some kind of a custom data structure that represents a parameter. In the simplest case, you have an ID, which is the ID you map this parameter to that's coming from your VST plugin. And then you have a name and a section name. The name being the top row on the display, as we've just seen the section name below that. I've created a constant standard vector here, filling out these parameters. So saying I have some IDs mapped, I have some names for them, and you can see here that sections where I want a section key on the display being shown, I actually put the string. If I don't want anything shown because the section is running at that point, I just put an empty string. So let's write this as well into a MessagePack chunk. Since we found these type defs very useful earlier, let me quickly put them into global scope. And again, here start with modeling the data I want to write in an adept way. Let's say, as I said, a parameter is a key value map. A page of parameters consists exactly of 8 parameters. So since we know it's exactly 8, let's take an STL array of parameters, 8 of them. And finally, the whole controller is a collection of parameter pages. So use an std vector over the pages. Straightforward one-to-one mapping modeling of the real thing into logical data structures. Since I prepared the input data being stored in STL vector, I also can use STL algorithms here to transform and carry them over to my MessagePack compliant type system. So in this case, I use std transform, pass in my input data, writing it to a newly created page. And finally, I have to supply a transformation lambda. Let's put this on a different line for readability. So since I'm in C++ 14 here, I can use auto type, which is my input parameter. And I have to hand back, let's say, a parameter p coming out of this lambda. And all I have to do, I have just to fill in the name coming from my input and the section name. And of course, most importantly, to actually have them actually mapped, I have to tell it which ID to map to. Did some mistake. Obviously, I did not switch to C++ 14. Obviously, in C++ 14, that would be possible, so let's make the compiler happy, giving him some more information. So we have now created one page. Let's go ahead, put this into a controller. And finally, we have to create the high-level mapping towards this controller from saying currently we're carrying this 8-knob layout towards the controller. And then finally, I can tell MessagePack to just please write this again to a temporary stream. Pack. And finally, write the chunk to the file as before. In this case, we have the NICA standing for NI controller assignment chunk, putting the data from this temporary buffer. Give the compiler some time to think. By running this program again, I overwrite the file we wrote earlier. So if I bring this up now. In this case, this is also again for Diva, and here you see it's representing this controller assignment I've just created. So again, native map allows you to create controller assignments and controller mappings tailored towards your individual plugin and for each preset you ship with your plugin. So say you have a modular synthesizer and you have different presets with different layouts. You can tailor these mappings for each different layout you ship. You store them into each individual preset file using the techniques I've just shown you. So you can also have a batch conversion adapted to your own software, integrated maybe with your own software if you like to.
So you've seen about the information about how to make native map work. So we're now in the browser, we now have native map, and it's all very, very fast to do. There's a few little additions to that, and they are view mode and save state. So these are optional things that we provide, and they're really for when you're using virtual instruments via complete control or machinist software, be it running standalone or be it running as a plugin. So there's two of these. First one, view modes. So what are view modes about? View modes are about a number of things. One is optimizing screen space, and the other one, which actually we think is more important, they give you a means to have two different views of your plugin, a simplified view and a default view. So what this helps you to do is, again, in the same vein as native map, it helps you to strip away and abstract complexity. So if you think about the pathway, you have native map, which is a very simple 8-knob multi-page layout. And the next level is that perhaps you have a simplified view of your plugin with key controls on top to start to encourage your users inside. And then the next step is your regular view. And I'm going to show you this by, again, just loading via the software. And I'm going to load rounds, which is, again, one of our instruments. It's a very, very complex instrument that I'll just show you a little bit more of in a moment. But this one has exactly these two views. So I'm going to close my control area. This one that you see here, it's very simple. It's a very deep instrument. It does an awful lot, but it's just got a very, very simple layout, very inviting for me to work with as a software interface. So we're not talking here now about the hardware, but about the software. If I click the little plus that has appeared, I get a slightly extended view. So there's not a lot more here, but it's giving me access to a number of different things. In this case, each cell and the synthesizer that each cell is using to create its sound. So they're the two views, very, very important things that we consider will help people to want to use more of the depth of your instruments. Second thing is save state, which is a little bit more of a utility feature. And what this does, it actually allows the plugin or the virtual instrument to say whether or not it's in a state where it can save a preset. That's something important just to make sure that it will only ever try to save at a point where it makes sense to save that preset.
Yeah, so obviously these are functionality of different functions that come in at runtime. So how do we make this happen? The VST Standard Offices a mechanism that allows us to use vendor-specific communication over the interface. In the SDK, you will find a header that defines a set of codes, operational codes for transactions and for different data types. You combine these using a high-low word logical OR combine to form an NKS opcode, which is then transmitted over the vendor-specific call in the VST SDK. So here in a nutshell, we see on the one hand the plugin, the host, and we have a communication from the plugin towards the host, which uses the property send command. And you use this, you bring over this call by implementing the vendor-specific call from the SDK. And on the other hand, the host can access, that is query with a get, or change with a set command, properties on the plugin. So give me quickly a look into another piece of code that you will receive with the SDK. The SDK contains a little demo plugin that shows you how to implement these features. And here we see, for instance, the host, the plugin implementation. So the host, the plugin overrides a function that is called can-do by the VST SDK, and it responds with a string defined in the header you will receive in this namespace of NKS vendor-specific extensions. If you respond with a true value, you will signal to the host, yes, we are NKS compatible, please send us these calls. And then you can use the virtual function vendor specific to receive these. The other way around, I have a function that I call notify NKS host. I first have to check, is the host an NKS host? Again, using the can host do function from the SDK, the VST SDK, using the predefined strings. And then I can send properties towards the host. So what does it mean for the features we've just shown you? For the view modes, that means we have property on the plugin side. The plugin carries a property that is available view modes. So it can tell you, I have a large view, I have a small view, can be docked. And you can query this from the host side with the get function. And you use the set to change this function, to change this property, obviously. The inhibit save is also just, in this case, a read-only property for the plugin. So the host just queries the plugin. Are you in a state where it makes sense for the user to save a preset now? So maybe you have like a rack where you have nothing in there, so it doesn't make actually sense to save something. Or we're talking about even maybe demo modes. So no authorization for the plugin is running in demo mode, you want to prevent the user from saving something.
So something that you will have gathered from my demos is that I'm using hardware and software. And a key part of NKS is that we don't just provide this umbrella for browsing and native map, but we also have some very high-end hardware that you can really control from your virtual instrument. So not all virtual instrument manufacturers want to or have the means to make hardware. So this is essentially a way of putting this kind of hands-on functionality, giving that to the end user. We've seen that with the native browser. We've also seen it with native map. But there's another feature that you may already be aware of, but if not, I'm sure you've spotted, which is the light guide that's running across the top of the keys. And this light guide, of course, is completely open for NKS developers. So it's something that you can use in various different ways. Why a light guide? Well, many contemporary VIs use note events to control expressive aspects of the sound. So it might be key switches, or it might be indicating a split, or it might be a pattern selection, or really anything else that you can dream up. And the light guide represents these through color, and then also combined with that on the display, we have text strings that just help the end user to actually play these instruments without having to have guesswork involved of where is my split, or if I press this key, is it going to play a sound? Is it going to change my sound between two different samples, or whatever it happens to do? So I'll show you this very, very briefly using, again, rounds, because that's the one that I had loaded up last, and one of our more entertaining presets for rounds called CraftBots. So what I'm going to do is play a key. Some of you've all heard before. Let's turn that down slightly. So what you can see is that the lower keys in my light guide are actually showing various bits of information. And what you may have noticed is that they actually reflect which cell is being played inside this particular synth. Because this particular synth has inside it a sequencer that it essentially steps through to get different variations on the sound. So I won't go into more detail about rounds, but you get the idea. So not only is it telling me that with the pink and yellow keys, but also if I press those, I can stick to a particular cell. So it's just a slightly more creative use, and even a segment of a particular cell, or two segments. So it's a very simple example, but this shows you some of the more creative possibilities of the light guide beyond things like key splits and other such things. So as I say, this is something that we open up through NKS SDK. It allows full control, right from these simple cases to these more elaborate ones. And it does this with 4 aspects. One is key color, one is key mode, key state, and key name.
Yes, you just may imagine that these properties that Tim has just mentioned to us, they are obviously properties the host can send towards the plugin sends towards the host. This is then forwarding them to the hardware. The SDK you will receive defines these, and they are explained in a separate header. One thing to notice these have to call, all these vendor-specific calls have to come from a non-time critical thread, so usually a UI thread. If you have to bridge stuff from the audio thread over, I think it's interesting to hear Timo's talk tomorrow, which is talking about log-free queuing, which is a good tool for that. So that was one example for the way from the plugin towards the host. So I'll hand back to Tim.
So to wrap things up, I want to talk about something else that's very important to us at Native Instruments and something that we've been working on more recently. It's a topic that's very close to us, and that's accessibility for visually impaired users. And we started this process with Complete Kontrol S-Series hardware. So everything we do so far today is via the hardware. Complete Kontrol only for now. Now, we know that accessibility is something that as a development community, we all care about it and we all want to do it. But we also know it's very, very difficult to implement it, especially when you're working cross-platform, so using different libraries and so on and so forth. So in order to address this, we've included hardware accessibility at the core of NKS. And the good thing about it, it requires absolutely no additional effort on the part of the vendor of the VST. You get all of this, you get meaningful accessibility without doing anything in addition to what you've seen already today. So I'm going to just demonstrate this very briefly, really as a wrap-up, just showing you how these features allow you to do everything we've seen today from Complete Kontrol hardware. And this applies to any of the sizes of the keyboard, 25 up to 88. So,
accessibility on.
First thing, turning accessibility on. This is done directly on the hardware. Browsing was the first thing we looked at, the native browser. So I'm going to press Browse.
Preset browse.
And it tells me which mode I'm in. Now if I touch any of these knobs,
Vendor, all vendors.
it will tell me the name of the parameter, and it will also tell me what it's currently set to. So here,
Product, rounds.
that's what I've been using, and I was using all
Banks, all banks.
and so on and so forth. So this allows me to find any of these instruments across this enormous library, every Native Instruments and NKS plugin that's out there, which, as Ray mentioned earlier, is a lot of products. It makes them immediately accessible and browsable. So I'm going to jump in and I'm going to use, in this
Vendors,
case,
all vendors. Yuhi,
I don't even need to tell you anymore, you can just hear it. So I'll just,
Diva.
and I'll load the first preset. So now that that's loaded up, I'm exited my browser. I'm no longer in native browser. I'm now inside native map. And that works in exactly the same way. But here, of course, we don't tell you the parameter value because actually you don't want to hear whether you're at 350 hertz, you just want to hear the sound and hear it evolving without text getting in your way. So now you'll hear just the section name
Filter, Reso.
and the parameter name announced.
LFO1.
Similarly, if I move across the pages,
Vco, Tune Mod, Pools WDTH, Sync and Cross Mod. Mix, Vibrato and PHP.
so it's telling me what's on each page as I get to it. So again, it
Vco,
allows
Tune Mod, Pools WDTH, Sync and Cross Mod.
it allows a mental map to be created by users who obviously cannot see the screen or see the controls because obviously everything is soft control.
Filter, Mod ENV, Phaser 1 and Plate 2.
That means that I can very easily adapt a sound
Filter, Qtoff.
without even being able to see anything, see the screen, see the hardware. The same theory applies to another feature that we haven't really talked about today, but it's something that's in there and lives on top of all plugins that are inside Complete Kontrol and inside Machina, and that's Smart Play. So I have Scale, for example,
Scale on. Scale edit.
where you'll see another use of the light guide,
Harmonizer. 1, 3, 5, 7.
and an
Arp
arpeggiator,
Arp edit.
working in exactly the same way.
Advanced. On. Main. Other. Dynamic. Advanced. Hold. On off. Off.
So that just shows you how we've added this kind of next level of usability, if you like. So it's a way of giving people who otherwise perhaps don't have any meaningful access to your virtual instruments a way in. And it's all done via the hardware. So currently not in the software, but really focusing on the hardware piece itself. So to finally summarize, talking about these features and talking about quality, I just want to mention one other aspect of the NKS SDK. So we've really shown you how NKS improves user experience, and it improves how you find and how you work with sounds. And of course, this is in the end really, really great news for the end user, because they can use a much wider palette of instruments, much wider sounds, whether they require accessibility or not. They can find exactly what they're looking for, tweak it, and work in a much, much faster way. And Of course, all of this works really great in DAWs as well. You'll have noticed the transport controls. We also have track selection, undo, redo in the major DAWs. So it's a really, really great way for people to work very, very fast. So in addition to this, with part of the SDK, what we do, we actively make sure we support the integrity of this experience. Because of course, if you have anything in there, it can become very disjointed. It can feel very cumbersome. So we have very, very detailed guidelines in the SDK, which I've already mentioned. We have things like a checklist that just allows you to say, okay, have I covered everything that I need to cover? And finally, we have a kind of approval process, which is all about supporting your quality assurance and really guaranteeing that across the board, you have this really, really great quality of experience. So the end user can, as I say, find anything, work with sounds, record, and so on and so forth in a way that just wasn't possible before. So for some final words of wrap up, I'm going to pass you back to Ray. Thanks very much for listening.
So thanks a lot, Tim and Eike, for the wonderful overview of the SDK. I hope you found it informative, inspiring, and encourages you to perhaps contact us and include it in your own products. We've obviously been talking a lot about instruments over the past hour, but that's just a starting point for us with NKS. We see extending the scope of NKS to effects in the near future. We feel that it would benefit from the same sort of things you've seen, such as preset browsing and parameter mapping. So that's definitely something that you can look forward to. As a final closing note, I would just like to iterate the fact that NKS is actually free to use and it's available for everybody. All you need to do is essentially contact us. You can do that over the email address there, by contacting us after the talk perhaps, or maybe asking us questions and talking about how you can integrate your products. Upon that note, I would hope we can welcome you to be a part of the NKS family, and I would say thank you.